Hello guys, in this video we're gonna see about edge computing. So what is edge computing? Edge computing is a distributed information technology in which client data is processed at the periphery of the network as close to the originating source as possible. Data is the lifeblood of modern business, providing valuable business insight and supporting real-time control over critical business processes and operations. Today's businesses are awash in an ocean of data, and huge amount of data can be routinely collected from sensors and IoT devices in real time from remote locations and in hospital operation environments almost anywhere in the world. But this virtual flood of data is also changing the way businesses handle computing. The traditional computing paradigm built on a centralized data center and everyday network is not well suited to moving endlessly growing rivers of real-world data. Bandwidth limitations, latency issues, and unpredictable network disruptions can all conspire to impair such efforts. Businesses are responding to these data challenges through the use of edge computing architecture. In simplest terms, edge computing moves some portion of storage and compute resources out of the central data center and closer to the source of the data itself, rather than transmitting raw data to the central data center for processing and analysis. That work is instead performed where the data is actually generated, whether that's a retail store, a factory floor, a sprawling utility, or across a smart city. Only the result of that computing work at the edge, such as real-time business insights, equipment maintenance, predictions, or other actionable answers, it's sent back to the main data center for review and other human interactions. Thus, edge computing is reshaping IT and business computing. How does edge computing work? Edge computing is all a matter of location. In traditional enterprise computing, data is produced at a client endpoint, such as a user's computer. That data is moved across a WAN, such as the internet, through the corporate LAN, where the data is stored and worked upon by an enterprise location. Results of that work are then conveyed back to the client endpoint. This remains a proven and time-tested approach to client-server computing for most typical business application. But the number of devices connected to the internet and the volume of data being produced by those devices and used by businesses is growing far too quickly for traditional data center infrastructures to accommodate. Gartner predicted that by 2025, 75% of enterprise-generated data will be created outside of centralized data centers. The prospect of moving so much of data in situations that can often be time or disruption sensitive puts incredible strain on the global internet, which itself is often subject to congestion and disruption. Why is edge computing important? Computing tasks demand suitable architectures, and the architecture that suits one type of computing task doesn't necessarily fill all types of computing tasks. Edge computing has emerged as a viable, important architecture that supports distributed computing to deploy compute and storage resources closer to, ideally in the same physical location as the data source. In general, distributed computing models are hardly new, and the concepts of remote offices, branch offices, data center location, and the cloud computing have a long and proven track record. But centralization can be challenging, demanding high levels of monitoring and control that are easily overlooked when moving away from a traditional centralized computing model. Edge computing has become relevant because it offers an effective solution to emerging network problems associated with moving enormous volumes of data that today's organizations produce and consume. It's not just a problem of amount, it's also a matter of time. Applications depend on processing and responses that are increasingly time sensitive. Consider the rise of self-driving cars. They will depend on intelligent traffic control signals. Cars and traffic controls will need to produce, analyze, and exchange data in real time. Multiply this requirement by huge number of autonomous vehicles and the scope of potential problems become clearer. This demand as a fast and responsive network. Edge and fog computing addresses three principal network limitations. One is bandwidth, latency, and congestion or reliability. Edge computing use cases and examples. In principle, edge computing techniques are used to collect, filter, process, and analyze data in place or at near the network edge. It's a powerful means of using data that can't be first moved to a centralized location, usually because the sheer volume of data makes such moves cost prohibitive, technologically impractical, or might otherwise violate compliance obligations such as data sovereignty. This definition has spawned myriad real-world examples and use cases. Some of the examples are manufacturing, farming, network optimization, workplace safety, improved healthcare, transportation, retail. What are the benefits of edge computing? Edge computing addresses vital infrastructure challenges such as bandwidth limitation, excess latency, and network congestion, but there are several potential additional benefits to edge computing that can make the approach appealing in other situations. Edge computing is useful where connectivity is unreliable or bandwidth is restricted because of the site's environmental characteristics. Examples include oil rigs, ships at sea, remote farms, or other remote locations such as rainforest or desert. Edge computing does the compute work on site, sometimes on the edge device itself, such as water quality sensors on water purifiers in remote villages, and can save data to transmit to a central point only when connectivity is available. By processing data locally, the amount of data to be sent can be vastly reduced, requiring far less bandwidth or connectivity time than might otherwise be necessary. Challenges of edge computing. Although edge computing offers benefits like data processing close to the source, it also creates a bevy of challenges for the network. Network bandwidth, distributed computing, latency, security, backup, data accumulation, control and management, scale. Edge computing, IoT, 5G possibilities. Edge computing continues to evolve using new technologies and practices to enhance its capabilities and performance. Perhaps the most noteworthy trend is edge availability, and edge services are expected to become available worldwide by 2028, where edge computing is often situation specific today. The technology is expected to become more ubiquitous and shift the way that the internet is used, bringing more abstraction and potential use cases for edge technology. Wireless communication technologies such as 5G and Wi-Fi 6 will also affect edge deployments and utilization in the coming years, enabling virtualization and automation capabilities that have yet to be explored, such as better vehicle autonomy and workload migrations to the edge, while making wireless networks more flexible and cost-effective. Edge computing gained notice with the rise of IoT and sudden glut of data such devices produce. But with IoT technologies still in relative infancy, the evolution of IoT devices will also have an impact on the future development of edge computing. One example of such future alternative is the development of micro-modular data centers. The MMDC is basically a data center in a box, putting a complete data center within the small mobile system that can be deployed closer to data, such as across a city or a region, to get computing much closer to data without putting the edge at the data proper. Thank you guys.